Hi everyone, welcome back. This is the second part of the workshop series where we'll be learning how to use Grasshopper. Grasshopper is a plugin for Rhino and it's used for parametric design and generative design. It's a form of coding in a way you probably don't really usually see coding. Parametric design and generative design, if you guys aren't too familiar with, it's just basically a way of designing using math and numbers and establishing relationships between those numbers and stuff. And so that way you can kind of have like a base design, but then create like, I'm not gonna say like millions, but you can create a bunch of different variations by kind of messing around with like number sliders and all that sort of stuff. So we're going to get started. Let me just share my screen and I'll actually turn on live transcript as well. Hopefully that'll help. Okay, screen share. Okay. So as you can see, I have my Grasshopper window already set up. I'm just going to save this really quick and then, oops, okay, all these Zoom notifications. Okay, and close it so I can show you how you would start up a file. So once you have Grasshopper, you can just open up Rhino, type Grasshopper into the command bar, and a new document will usually pop up. But since I've opened my Grasshopper file first, that's what's showing up. So as you can see, Grasshopper works using a bunch of components that are connected to each other with wires. Look like this. You can access all of these different components in these tabs up here, but I find the best way to do it is just to double click on the board and then type in whatever component you're looking for. A rectangle, something like that. I find it easier just because I cannot, for the life of me, remember where components are under those tabs. And also it's super handy because if you're not sure exactly what component you're looking for, but you have an idea of what it should be doing, you can type it in and then there'll be a whole menu of different suggestions. And so that's super helpful as well. So basically data flows from left to right through these wires into these components. And you can see that you can also kind of look at what are like the numbers or what's coming out of each component by putting in a panel and connecting it. So here you can see out of the rectangle component, well, the R here stands for rectangle. If you hover over the little letter, I'll tell you. And you can see in the panel, it says a rectangle, and this is the width, and this is the height. What does this one say? This says length. So you can also plug that in, and it says this is the length of the rectangle. So again, to get the panel, you can double click, and then it's just 2 slashes to pull up the panel. And that's super useful if there's anything wrong with your code and you're like, why isn't this working? Always kind of look at the data, look at what's showing up, and that'll kind of help you figure that out. You can see here there are number sliders. That's how you can change things very quickly. And what's nice about Rhino and Grasshopper and the way it works is that you can reference geometry that's in Rhino in Grasshopper, and you can also bake any geometry that you've created in Grasshopper into Rhino. So I'll show you what I mean by that. Let's say that I draw a rectangle in Rhino, and usually it's something a little more complicated. You can easily make a rectangle in Grasshopper. But let's say it's a complicated shape and it's easier to make it in Rhino. And then I want to use it in Grasshopper. I'll take the curve tool, or I'll put down a curve component, And then I can right click it and go set one curve, click on that curve, and now that curve is in Grasshopper. I can also do the opposite. I can make a rectangle, and I'll explain a little bit more later. I can make a rectangle. Let me delete this so it's not confusing for you guys. I can make a rectangle in Grasshopper, and then I can go right click and bake. And I only have one layer set up, the default layer, but I can bake that into Grasshopper and then delete it here. And here it is in my Rhino. So usually once you're done creating your design, you bake the whole thing into Rhino, and then from there you can start making slices and doing your drawings and all that sort of stuff. Let's see what else. Set up things, I guess. The way that my Grasshopper is set up, I have it set up just so that I can only see geometry that I click on. So here you can see it's just whatever I click on. And as you can see, whatever component you click on, that geometry will show up in green in Rhino. You can also set it up so that you see all the geometry and you don't have to click on it. I find that this is pretty confusing though, because there's just so much to look at. So it's definitely easier for me to just kind of do it so that it only shows what I ask it to show. And again, that's just those buttons over here. And if I want to show multiple things, I'll just click on the component, hold shift, and then click on the other components as well. Another thing is these components can be shown in different ways. So you can right click display, and then you can ask it to draw icons. So instead it'll look like this, or you can ask it to draw full names. I find when I was starting out, this was super helpful because then I could see exactly what each thing was, like plane, X size, Y size, radius, whatever. But now I'm kind of more used to it like this. So that's how I'm going to leave it. You can see that my code here is organized in these little clusters. It's super important to keep your code nice and clean so you know what's going on. You can even label the clusters, and you just do that by selecting all your components, right clicking and clicking group. And then you can right click the group again, and you can name it something. I think these ones were floor plates. Yeah. So that's just a kind of quick overview about the kind of setup and basic stuff for Grasshopper. Now we're going to kind of go through designing a building, and just like last time when we designed a building that's inspired by my hall, we're going to do the same thing here. And I already have the code set up. I think it maybe is easier for you guys if you see kind of what connects to what, and it helps you kind of see what goes on. So here I put down a rectangle component. You can see it in Rhino. And I decided that the length and the width would be 25 and 30. And I can change these pretty quickly just by moving them around. My computer's kind of lagging a bit. I think it's like Zoom and stuff all working together. But 25 and 30. These are called number sliders. So again, I can just put in a number slider. And then to change the name, I can right click and this menu pops up, and I can call it length or width or whatever. And then I can set a maximum in. So the minimum should be 0 if it's talking about the length of the building, and the maximum we can say like, I don't know, 100. I'm working in meters. And basically you just want to make sure that your Rhino file is in meters, and then it'll be in meters in Grasshopper as well. These are different types of numbers you can have. So like decimal, whatever. Yeah. So to connect, to connect your number sliders, sorry, it's being a little slow. Simply drag from this little node to whichever one you want, like, oops, like this. And to disconnect them, you control and go that way, the opposite way, right to left. As you can see, if I connect one to the next, oh, it's so slow. I'm sorry, you guys. It just kind of replaces the other one. So if you want them both to show, well, in this case, you can't really have both because it wouldn't make sense to have both 30 and 25 as the X length. You would hold, so I'll get an error, but I'll show you anyways. You hold shift and connect it, and then both will be connected. Oh, I didn't get an error. Oh, I didn't even know that was a thing. Okay. I didn't get an error. That's kind of cool. I didn't know that. Yeah, so I'm gonna go ahead and connect. You can also connect it to multiple, as you can see. I'm gonna go ahead and put it back to normal. Okay. So this rectangle represents the outline of the floor. So then what I'm gonna do is I'm gonna go ahead, and if I want to know the floor area, I can connect the rectangle to the area command. This G is for geometry. So it's collecting the rectangle as its geometry, and the A is area, and I connected it to a panel, and it says that my area is 750, which is what my hole's area is. So that's also a super useful way to use Grasshopper, especially if you have super weird shapes. Just throw it in to Grasshopper and it'll compute the area for you. So with this rectangle, I'm going to go and put down a boundary component, boundary surfaces, and it's going to create a flat surface out of that rectangle. And the E is edges. So the rectangle acts as the edges for the rectangle, for the surface. From there, I'm going to go ahead and extrude it. As you can see, that's going to create the thickness for my floor plate. And so that Grasshopper knows how much to extrude it by. It's going to ask you to fill in this input here, the direction. So the direction is the Z, because you want to extrude it up for the thickness. So unit Z, and then a number slider, which I call floor thickness. And as you can see here, I've just kind of included a panel so I know what's going on. Let's see. So now I want to have multiple floors. So what I'm going to do is I'm going to put in this linear array or array linear component. So I'm just going to connect the extruded floor plate into the geometry because that's what I want to be extruded. Again, I'm going to array it in the X direction because obviously the floor plates are stacked right on top of each other. And I want the floor heights to be 3 meters between each floor. And I also want, so 3 meters between each floor, which means it has to be 3 meters plus the floor plate thickness. So I'm going to go ahead and put an addition command, and I'm going to add the floor plate thickness to the floor heights, or that should actually say ceiling heights. I'm going to change that. Heights. And the result is what I'm going to put into the F. F is the factor. So it's going to array in the X direction by a factor of 3.3 meters. And then the last input for array linear is the count, and I want there to be 8 floors. So that's what we have here. As you can see, if I was to do this in Rhino and I wanted a bunch of different versions, I might have to create all these different versions in Rhino, maybe one with 8 floors, one with 10 floors, and kind of like play around with it. Whereas this, it's very quick to see what the building would look like if it had 6 or 10 or 12 or 100 floors. Okay, so those are our floor plates, as you can see. The next thing I'm going to do is I'm going to do the exterior walls. And the exterior walls I'm going to do by moving the original. You can see, you can kind of trace it back. By moving this original rectangle up. And I'm going to move it up again in the Z direction by a multiplication of the number of floors and the height or the distance, right? Which again is going to be 3 meters plus the floor thickness. And so that will give me an exterior wall that will go all the way, sorry. That will give me an exterior wall that will go all the way up. And then I'll put a roof on top of it. So you can kind of see there's like a logic. You might need to like develop the logic, and it'll like start to make sense. Like, okay, you need an exterior wall for an 8-floor building, and this is how tall each floor is. So that's how tall I need my wall to be. So I've moved my rectangle up to the height that I need it to be. But I'm also going to offset the same rectangle here by a wall thickness amount and extrude it so that I have an exterior wall. Cool. Again, by the same factor as the original move. So that's my exterior wall. And then I'm going to create the roof, again, using the same rectangle that I've moved up. I'm going to create a boundary surface and extrude by the same amount as the floor plate, I think. I think I did by the same amount as the floor plate. Yeah. So that's the roof. So now you can kind of see I have the floors, I have the exterior wall, I have the roof, and now we're going to make the mechanical box on top of it. So the mechanical box is the same size as the roof, but it's a bit smaller. It's inside, it's not flush with the exterior walls. So I'm going to offset it, create the surface, extrude it up to create the mechanical box. And I extruded it by a factor of 3 meters. You can make it however big you want, of course, using the number sliders. Cool. So now we're going to create the facade, or just one facade. And it's not going to be the exact same, but it's going to be pretty similar or have a similar vibe. So you can see here, I'm going to loft the, I'm going to loft the between, let me do this. Where is it here? I'm going to loft between the first rectangle that's on the ground and the rectangle that I've moved up to the top of the building. And so what that's going to do is it's just going to create a surface between the two curves. I think we might have done that command in Rhino as well. So that's creating the exterior facade surface. And then we're going to debrep. So debrep will deconstruct the geometry into its faces, its edges, and its vertices. And you can see it's all the faces, edges, and then the corners, the vertices. Then I'm going to split up the faces into each individual face so that I can work each face at a time. And that's just by going into list item. Again, here, list item. Connect the face to the list, or that's like the faces is the original list. So if I put in a panel, it might make a bit more sense. So the faces that come out, there's a list of 4 surfaces. And so that's the list that we are going to pull a number from. So to set which face that you're picking, you would change it in the index. So right click I, set integer. So this one is set as 0. This one is set as 1, 2, 3. And so you can see each list item is a different surface or a different face. And you can also, so what you're going to want to do for this next part is reparameterize the surface. And so basically that means that whatever numbers that comes out of the list item, or whatever numbers are associated with each face, it's going to reparameterize them so that it's between 0 and 1. And that'll help us in the next step, where we divide up the face into kind of like a grid. Well, that's exactly what it is. It's a grid to create like a pattern for the facade. So we're just going to work with this one face for now. And what we're going to do is put in a subsurf command, which is isotrim. I don't know why it's a subsurf. It's isotrim. Like, it doesn't, usually they make sense, you know, like surface is anyways. Subsurface. And again, it needs kind of a domain, or like what to divide it by. So we're going to connect it to a divide command or component. And then we're going to say U count and V count. So it's kind of like how much you want to divide the surface by. You can see all these lines, right? So you can see that we have 8 going like in the Z direction, and we have 15 going across kind of like the X and Y direction. So that's just kind of like, it tells basically how much to divide the surface by. And you can change these, of course, to have like a bunch of different like rectangles, or you can have as few or as many as you like. I did 8 because it corresponds to the number of floors there are. So yeah, at subsurface, you can see this divide component, or divide domain squared component, it's grayed out. And when you click it, it doesn't show any geometry because it's not, there's no really geometry associated with it. It's just kind of like it's kind of like, it's just something that the subsurface references or uses as like a base, if that makes sense. It just uses like the numbers from the divide. You can, like, if I put in a panel, you can see like all the different little guys that pop in. Okay, cool. The next thing is we're going to play with each rectangle to create the sort of pattern, or the sort of 3D volumetric shape. If you guys remember, my hall has this kind of like beams and columns that divide up each window. So we're going to create that pattern. And so whenever I'm creating kind of like a facade component, I like to work with just one of them. Where did it go? Over here. So again, that's just list item. And I find it's just easier, and it's easier on your computer too, to just work with one and then apply it to a bunch after. So I'm going to go ahead and connect it here. So kind of the same idea, we're going to deconstruct it into its different components. I keep saying components, and they all, every time I say components, it means a different thing. But we're going to deconstruct it, and taking the edges, we're going to join it so that it's one curve, because otherwise it'll just be 4 separate curves. And we're going to offset the curve in a little bit and create a boundary surface. And then we're going to extrude it outwards. And so that creates a little rectangle. And we're going to do the exact same thing for the outside. So taking the face of it'll make a little more sense. I'll show you. Taking the face now, we're going to extrude that to create a box. Again, we're going to extrude it by the same amount that we extruded the offsetted one. And so you can see you have sort of like one square or one box with another little box inside it. Then what we're going to do is we're going to surface difference. So we're going to extract the inside box from the outside box to create that frame. And it looks like this. Surface difference, or sorry, not surface difference, solid difference. And again, this is the bigger one, so we're going to subtract the smaller one from it. And then we can apply that to the entire facade. We can zoom in here by kind of skipping this item and just going straight from surface to, you know, it's going to take a little while. But you can see now I have, oh, I think this might have gone the wrong way. Oops, give me 1 second. Here we are, surface difference. I was clicked on the wrong thing. But that creates the frame that's on the My Hall facade. And again, you can bake it. You can bake everything into Rhino. You can also apply the same facade to the other faces, the other facades. But that's basically it. This is just one way of doing it. There's a lot of different ways that you can do it. There's a lot more you can do with Grasshopper. This is kind of just like the beginning. But yeah, also I know like kind of a lot of information at the start. So yeah,